Hey everybody. Today we're getting some practice calculating with the t-distribution. Here are the 4 problems we're going to cover. I recommend pausing the video and working through these on your own. The first 2 are asking for probabilities, giving some values in t-distributions. The second 2 are asking you for values given probabilities. Problem 1, find the probability that t is greater than 0.44 in t of 26. So in other words, the t-distribution with 26 degrees of freedom. So this probability corresponds to the area to the right of t equals 0.44 under the graph of t of 26. In order to compute it, we're first going to find the area to the left using the cumulative distribution function, or CDF, and then subtract from the total area 1. You should do CDF calculations for a t-distribution using technology. I use R, where the command is pt of x comma n. That's the probability to the left of the value x under the distribution t of n, so n degrees of freedom, like I've got it pictured here. So, to find the probability that t is greater than 0.44 in t of 26, we do 1 minus the probability that t is less than or equal to 0.44. 1 minus pt, 0.44 comma 26, it's about 33.18%. Problem 2. Find the probability that t is between negative 0.8 and positive 0.5 in t of 19. So I've sketched the area here. We want to find that area. And we'll do that by taking the area to the left of 0.5 and then subtracting off the area to the left of negative 0.8. Basically, that means subtracting 2 pt's, pt of 0.5 comma 19 minus pt of negative 0.8 comma 19. We get about 47.18%. Problem 3. Find a value tau such that probability that t is less than tau is 0.3 in t of 50. So as I mentioned earlier, here we're given a probability and asked to find the t value that has that area to the left, that probability to the left. So this is an inverse CDF problem. You should do this using technology too. In R, the command is qt of p comma n, where p is the cumulative probability at the value you're trying to find, and n is the number of degrees of freedom. In this case, we want to find the value that has 30% of the area to the left, 30% of the probability to the left. So the command we're doing is qt of 0.3 comma 50. And we get about negative 0.53. By the way, if we were then to do pt of negative 0.53 comma 50, we should get 30% up to potentially some rounding error. Problem 4. Find the value tau such that the probability that t is between negative tau and positive tau is 95% in t of 12, as I have pictured here. So the big challenge is that the number 0.95 is not a cumulative probability. It's not a percentile, an area to the left of a value. And so we can't just plug it into an inverse normal CDF like qt. What we need to do is to find the area to the left of the value tau and then plug that into qt. So we're going to use symmetry here. We have 95% of this area shaded between negative tau and positive tau. So we have 5% unshaded. And of that, 2.5% has to be unshaded on the left, and the other 2.5% is unshaded on the right. All told, the area to the left of tau is 97.5% of the total area here. So the value tau is qt of 0.975 comma 12, about 2.1788. So that's the value that captures 95% of the area under this graph between negative tau and positive tau.